Shape and symmetry. In this section, we are going to work with shape and symmetry. Look at the picture of my dog. My dog Ninja has a perfectly symmetrical face. This line is the line of symmetry. The left or right part of the face can be folded because there is line symmetry. In order to understand shape and symmetry, let us have a look at parabola. A parabola has this equation. Y is equal to ax squared plus q, and this is called the standard form equation. Look at this equation. Look at the a which is next to x squared. If a is negative or a is less than 0, the graph will be a set or frowning face. The shape will be like this. Remember that this sign, which is less than 0, means negative. Let us have a look at when a is greater than 0. If a is greater than 0 or positive, then the graph will be a smiling face. Look at the shape of the graph. This sign, greater than 0, means positive. It is important to know that a, which is the number or letter next to x squared, determines the shape of the graph. Look at this equation again. If y is equal to ax squared plus q, in this equation, a cannot be equal to 0.
Phoenix, tell us why a cannot be equal to 0.
Let us put 0 in the place of a, and let us see what happens. If we put 0 in the place of a, we will have y is equal to 0 in bracket multiplied by x squared plus q. Look at this part. 0 multiplied by x squared is equal to 0. So 0 plus q is equal to q. So y is equal to q. When x is equal to 0, our x squared term disappears. This equation, which is y is equal to q, is no longer a parabola. Look at the equation y is equal to ax squared plus q. A cannot be equal to 0. We write it like this. Let's quickly have a look at the graph of y is equal to x squared. This line is called the axis of symmetry. This line is the y-axis. So we can say the axis of symmetry is given by x is equal to 0.
Why do you call the line the axis of symmetry?
Look at the graph. Let us remove the x-axis to help you understand better. The two sides of a graph are like mirror images of each other. This shaded part is symmetrical to the unshaded part. The axis of symmetry is this line. This axis of symmetry is at x is equal to 0. Look at these three graphs. In each case, look at the sign of the number next to x squared. Look at this equation. And this equation is y is equal to x squared. In this case, the number next to x squared is positive 1, which is positive. Look at the second and third equations. The graph will have a smiling face. Let us now have a look at hyperbola. Look at the graph of y is equal to 4 over x. Let us draw a straight line that passes through this point, the origin, and this other point. Our straight line should look like this. Look at this point. This first 2 is our x-coordinate. This second 2 is our y-coordinate. At this point, x and y are equal. Look at this other point. Look at the first -2. This -2 is our x-coordinate. Look at this second -2. This second -2 is our y-coordinate. At this other point, x and y are equal. So we can say this point and this other point lie on a straight line y is equal to x. Look at this graph. The graph you are seeing is the graph of xy is equal to 4. xy is equal to 4 can be written as y is equal to 4 over x. It's important to know that xy is equal to 4 is the same as y is equal to 4 over x. Let us draw line y is equal to x. The line y is equal to x passes through the origin. Look at the graph. Here is line y is equal to x. Let us call this point 1 and 4. This means x is equal to 1 and y is equal to 4 at this point. Let us call this other point 4 and 1. This means x is equal to 4 and y is equal to 1 at this other point. Look at this point and look at this other point. What do you notice?
1 and 4 were swapped to be 4 and 1.
This is true. Look at this point. At this point, x is equal to 1 and y is equal to 4. Look at this other point quickly. At this other point, x is equal to 4 and y is equal to 1. This point and this other point are symmetrical with respect to the line y is equal to x. So we can say point 1 and 4 and point 4 and 1 are symmetrical with respect to line y is equal to x. Look at the graph again. Let us add line y is equal to -x. Line y is equal to -x will be perpendicular to the line y is equal to x, and it will also pass through the origin. Look at the graph. Look at this point. This point has coordinates 4 and 1, which means x is equal to 4 and y is equal to 1. Look at this other point. This other point has coordinates -1 and -4, which means x is equal to -1 and y is equal to -4. This point and this other point are symmetrical with respect to line y is equal to -x. So we can say the point 4 and 1 and the point -1 and -4 are symmetrical with respect to line y is equal to -x. Look at this point and this other point. What do you notice?
4 and 1 were swapped.
I totally agree. 4 and 1 were swapped. Look at the signs. What can you tell me?
After swapping 4 and 1, they changed both signs.
Digit, I taught you well. The coordinates were swapped, then they changed both signs. Mathematically, we write it like this. This is the first point. Point A and B. This sign means we are applying a transformation. The point minus B and minus A are the coordinates after the transformation. Let us have a look at this example. Study the graph. In this example, they want us to use the given graph to answer the questions. Let us start with the first question. Let us determine the equation of the hyperbola. Look at the graph. Look at this point. This 8 is our x-coordinate. This 2 is our y-coordinate. Together, 8 and 2 are called coordinates, or we say 8 and 2 is an ordered pair. Let us write down the defining equation of a hyperbola, which is xy is equal to k. In the place of x, let us put 8. And in the place of y, let us put 2. So far we have 8 multiplied by 2 is equal to k. Look at the left-hand side of the equation. 8 multiplied by 2 is equal to 16. So we can say 16 is equal to k. Let us now substitute 16 for k in the equation xy is equal to k. Our defining equation will be xy is equal to 16. Let us have a look at the second question. Let us find the coordinates of point B. Point B is here. Point B lies on the line y is equal to x. So the x-coordinate of point B must be the same as the y-coordinate. Look at point B. Let us look for two equal numbers that must be multiplied to give us 16.
4 and 4.
That's true, Digit. 4 multiplied by 4 is equal to 16. So, the coordinates of point B are 4 and 4. This 4 is our x-coordinate. This other 4 is our y-coordinate. Let us have a look at the third question. We know that point 8 and 2 and point A are symmetrical about the line y is equal to x. Look at the rule. If we have point A and B, we are going to solve the coordinates if we are reflecting on the line y is equal to x. To transform any point on the line y is equal to x, we swap the coordinates. So that simply means point 8 and 2 will become 2 and 8. So the coordinates of point A will be 2 and 8. Now that you have worked with shape and symmetry, let us see if you can try the following activity.
The first one has been done for you.